All right, so we're going to try something a little different here. Our wonderful conference hosts asked us to try to talk about the history of how our long partnership got us into AI and computer vision and ag. And they asked us to keep it casual and not appear too scripted. I appreciate the optimism that I have enough brain cells left to actually follow a script. So mission accomplished here already. I want to kick us off, just give a short intro of who we are. I'm Chris Freeberg-Horton. I'm a platform director here at the Plant Sciences Initiative and a professor of crop and soil systems. I would say that the exciting thing about here today is looking back to where we were 10 years ago and to what we have created now. It has been a whirlwind, and it's nice to have a moment of reflection on it. Stephen?
Agreed, yeah. So Stephen Mirsky, I'm with USDA Agricultural Research Service. I'm their new Director of Digital Agriculture, and so representing the digital agriculture efforts at ARS, and also here to represent DASH, which is the Digital Ag Systems Hub, and developing a lot of computer vision solutions across the agency and beyond. And it's good to sit up here with you and be chatting.
So Stephen, you want to kick us off just, I don't know, a little bit of what got you, how we started our drift from field agronomy into all of this craziness we now do.
Yeah. So, it was only like 20 years ago that Chris and I were having this ongoing competition about who could fine-tune our planter better, or who might be able to do better high residue cultivation with our, various different cultivating units. And I think those early years when we were working together, a lot of our papers, a lot of our products was, well, last year was the wettest year in recorded history. This year's the driest year in recorded history. Our graduate student has like 4 or 5 site years of data to basically make sense of that noise and then publish a paper. And I guess it got kind of dissatisfying, that we were constantly struggling to link up information about climate, soil, and management, and how we could sort of build, real impact from those kinds of papers and those kinds of products. So I think it lit a fire, I know, in both of us, how can we be more impactful? How can we leave sort of some kind of influence on these ag systems in a way that is not just these sort of little one and dones? And so that's when I think we went down this path of how do we do sort of highly coordinated science? How do we bring together the public sector to do distributed research, to be able to be collecting similar things that we can build the story around how climate, soil, and management intersect. And so that took us down this, I guess, wild ride of how do you get all the humans to do the same thing? How do you collect the same data? How do you get everybody to agree on the sensors they're gonna deploy, and then deploying that at scale? So I think that's been a challenge, but a lot of fun. How about you?
I certainly loved all of that distributed science, and I still love it. I did not expect we were going to be making custom apps as a result of it, but I think where I really got engaged, though, too, is on the extension side. So I am still a half-time extension specialist, and dealing in sustainability practices. My extension bulletins were terrible. I actually cringe. I had to go renew one recently, and I was like, God, what they really suffered from is that they are complex phenomenon. All of us are trying to deal with an extension, and we say, well, you have to consider all of this, or the old saying, it depends in extension, right? And so we say, well, and I had one that I wrote this sentence. I said, well, if you're going to explore this practice, you need to think about the next 12 things, and then 3 pages later, I've got a paragraph of all the 12 things you're supposed to think about. And one of the farmers that I worked with closely called me one day and he said, I've already been doing the thinking now what the hell am I supposed to do? And I was like, fair enough, right? And I think so then really software is where we can deal with that complexity in a much cleaner format than the it depends, right? And so those first decision support apps where we were able to pull in real time that farmer's soil's data. Tell me which field you're in. Oh, I see what soil you're dealing with. Oh, I see what kind of weather norms you've got. I see what kind of weather you had yesterday, right? And so I can filter out a lot of that complexity in real time and give them an answer like, I think you should do this. I mean, probably nice to put some uncertainty on that, but still, it's a lot more direct advice to be able to offer than let's think about all this complicated stuff. Do you remember, Stephen? I mean, the software march started, I guess it was 10, 11 years ago now, but our first computer vision target, when that wandered into our lives and what that was like.
Yeah, yeah. I mean, it came at sort of this time where, okay, so we're like, how do you do highly coordinated distributed science? Like, how do we get like land grant universities and ARSs to do sort of, hundreds of site years of data collection on farms? And so first it was a lot of like playing around with, multispectral sensors and sort of like an early foray into RGB just for like, like a coverage or something type of situation. And there was so many problems with all of those sensors and all those types of ways that we were taking measurements. And we started looking out from within what we were doing and seeing that people were having a lot of success with RGB, right? And they are using that to be able to build sort of computer vision models and get better sort of inference about what's going on out there. And at the same time, we were like, while we were struggling with these sensors that we were currently using, we were also having this issue of that, like, most of what we were doing across the country was dealing with problems like mapping weeds, right? And weeds are messy. For those of you who are, weed scientists or working with weeds or trying to control weeds, you can have like 20 trials grow out in a single year, and you don't know if you're going to have weeds in those fields, or you're going to be a weed scientist and you're going to be dumping weed seeds into those fields to have like uniform populations. And so how do you map spatial variability? How do you map that messiness? And how can you get tools into everybody's hands that can collect some kind of common data set or around the competition between weeds and crops? And so I'm not even sure, like, I think that we brought in sort of the first computer vision specialist into our lab, I don't know what it was, like 8 years ago or so now, 9 years ago. And she had been busy mapping the ripening of coffee beans. And she's like, yeah, I think we can map those weeds. And so then it was, all right, let's start to coordinate the team around building the imagery that we need to train the models to do the thing. And so then I myself come out of a weed science background, so a lot of the weed scientists have the same problem and the same need, and we started to discover folks in Denmark that were having a lot of success with developing weed mapping technology and what they were doing with sort of how they were building image repos. And so it made a lot of sense and it fit our equation really well. And so that became a very obvious first step. But then it sort of snowballed into, we need these images and these systems for this specific application, but we're now sort of branching out into more and more targets. There's more and more needs, and how do we sort of meet those needs, right? Computer vision is not a single solution in agriculture, right? We're not trying to we have so many needs, right? It's a million and one solutions, if you will. And so how do we build the training data to support sort of that enterprise so that we can create like a public good, if you will, right? And that's sort of what spawned the Ag Image Repo efforts.
Can you describe that, what's going on and where we're at with the Ag Image Repository and what your hopes for it are?
Yeah. So, I mean, it started really much in the weeds, right? How do we build an inventory of weeds that then we can map the species, we can map the biomass, and then we can create that public good, right? So that we can essentially not be the only ones that have access to this incredibly expensive data set, right? It takes a lot of money and a lot of time and a lot of people to build out these Ag Image repos. And so the idea for us was, how could we create like a public good, an open access resource of high quality, curated images that are annotated that anybody could use to build a model and feed into their own program. So yeah, sure, we were using it to target our research question and our mission focus, but really the goal has been, how can we create this more broader public good, the digitizing of agriculture, if you will. And I think that's been sort of now a core mission of what we are doing in the agency and DASH. It's been this core partnership with NCSU, is how do we go about peeling off target after target, standardizing that data collection, standardizing the way we can serve up those resources and making it accessible not just to ARS scientists, but to universities and beyond. And so that's sort of where we're at with it. And I guess maybe you could speak a little bit about the computer vision efforts from your side, and also how I mean, we've done a lot to create imagery to build models, but then the deployment of this models and how can we can scale that and make that a sort of a public resource as well.
Yeah, and I think, I mean, this is near and dear to my heart because I think when we got started, I mean, our very first project, we actually hacked GoPro cameras and we're distributing them around the country. And then we had an application that tied into those GoPros, and we were doing at scale this mapping. I think we had the last time we rolled it out, we had 25 states that were all doing this. Hacking GoPros and maintaining that hack for years at a time, not a good process. And so we've gone down the road of having everything else that everybody, probably half of the people in this room have been down this track of, well, then we could try it with a Raspberry Pi camera, or you could work with an engineer and try to develop your own camera. And then if you get something hacked together, what is your, how is that making it out to the grower at the end of the day? Who's going to then take that next step? And so we have a lot of camera projects that have been developed here around the country. And one of the things that makes me passionate is how do we bring us all together to have a community where we actually have a software ecosystem that is community supported and is maintainable and deployable, so that the public sector has a larger role with this entire rollout. I think we really have to step in and be govern our own destiny for how we do this. And if we just wait and let the private sector tell us how we collaborate, then we might not like how that's done. I remember one of the companies early on that wanted to collaborate with us said, you know, well, we will let you borrow our robot and imaging system for a couple of years, and you will provide the grad students and all the training data and write the paper about it, and then we will retain all the data and the model. That's an interesting notion of collaboration, really. So can we make something more collaborative out of that? And I think we can. And that's something we've been working on very hard. And I think the other aspect of it for us right now is where are we at in the technology development pipeline? I think our robotic overlords will be here in, 15, 20 years in ag, right? That we will be fully robotic. I think Stephen and I both firmly believe that. In the in-between time right now, though, particularly for we work in corn, soybean, wheat, cotton, the big row crops, it's still going to be this big machinery. And that big machinery, if a machine goes through a field, it should be strapped to the teeth with cameras everywhere. We should not have anything running through a field without a camera mapping something that might inform our next practice in it. And we can do that very cheaply right now. And so I think that's what really motivates me. How do we get our costs for camera systems down? How do we create an environment where the entire public sector is helping contribute to this? Like Stephen said, I love that. It's 1,000,001 use cases. That's very true, and that's very different from, I always like to tease the self-driving car people because I'm like, you got one task. I mean, a stop sign looks like a stop sign all across America. Yeah. You're basically doing one thing. I'm sorry, I'm teasing the engineers. If you do self-driving cars, my apologies. But in ag, right? A soybean plant doesn't even look like a soybean if you're in Nebraska or if you're in California, right? So nothing looks the same. The number of targets that we have is literally endless. So this isn't the work of one company or one group. It's going to be a collective work of all these disciplines trying to train around disease and insects and abiotic stress. And so we have to set the tone, I guess, in the public sector for how that community can come together to accomplish this work of our generation. Yeah.
I'm not even sure that it's just setting the tone, right? I mean, it's almost an impossible task to assume that we're going to have that peeled off any other way.
Yeah.
Right? Like so many of these targets that we need in agriculture don't come with a high ROI. Right? Like they're critical needs. They're serving, maybe it's serving researchers. Maybe it's like rapidly accelerating, putting new germplasm into the landscape. And it's being deployed in farmers, tractors and their systems. But many of those applications don't come with a high ROI. So they're going to get targeted late. Some of these things could have, big impacts on, long-term soil health management, or it could have, the implications for, pest outbreaks that don't necessarily fit, the model of a high ROI. And so I think it's almost our responsibility, in the public sector to do this, right? And so, I think that's what Ag Image Repo is about, right? It's this public good. It's living on the USDA's high performance cluster SciNet. We've got SciNet in the house today, so I
Good plug.
certainly needed to plug that. But then it's also going to be, created on a cloud instance as well, so it'll become a public resource and a public good that everybody can build on it. So everywhere I go, every company I talk to, every sort of researcher I talk to, they talk about the challenge of pivoting. Right? It is hard to pivot. It's hard to be nimble in this game, right? Like if I built an actuator that works on lettuce and I've put a lot of money and time into this and I've got my seed money or my Series A or whatever it is, I'm like, that's my roadmap. I got to knock that out. And if I hit any bumps in that roadmap that I can't hit that target, it's not like I'm pivoting to tomatoes tomorrow, right? It's like that you're done. And so I think it's the responsibility of create that, like we're trying to de-risk and elevate and accelerate transition to autonomy. And that's what building that training data is. And what you're talking about on the other side of this, I think really is a core support to the researchers in the room, right? It's like we need this open, building the training data, having the imagery, bottleneck, no doubt. But as researchers and breeders, you're developing models. Well, how are you deploying this model? Where does that model go? How are you putting it into your research program and then making value out of that, right? We don't have these open access platforms that we can build on and innovate together. So I think it's a timely thing.
Yeah. Well, I really like your point too about I think there's that academia and ARS can play this role right now in helping create an even playing field for all the companies. I absolutely believe that. I also think, though, that it's a great point. The ROI for some targets are not high. And that is a place that the agency and the land grants have always existed as well. I'll give a good example because I was not really aware that how different the land grant mission is for folks that might not be here. So I have a lot of College of Engineering colleagues now in our new shiny plant sciences building. And we've all learned about how different our lives are. It's been wonderful to explore. But if you're in the College of Ag side, we have long-term projects that we've been doing as a public service for since the dawn of time. Like when I got handed in, I remember them handing me and I said, okay, this is the North Carolina Pesticide Manual. Chris, this is where your contribution will be every year. Don't be late, right? And I got handed these technical bulletins that a predecessor had written. Like, those are now yours. You will have to keep them up to date. Why do we do those things? Because we serve our growers, and there are some things that our growers need that is very hard for a company to monetize, but yet it's still a very real need. And so we're also going to be finding that niche. What is the AI equivalent here, I guess, is what we're after, right? What is the AI equivalent of the North Carolina pesticide guide? I think there's a lot of those that we're going to find, and we need to get started on all those. And then maybe I can stop approving those chapters every year. It's still kind of a task.
You want to open it up to some questions?
Yes, we said we'd leave time for questions. We have 12 minutes. Thanks for the media clock. So,
floor is open.
wow, we can go on because that
There's one.
Howdy, I'm Leo Rivera with Texas A&M. Sorry. So I think one I could throw out to you for extension services might be helpful is just the amount of tools out there, AI or otherwise. I mean, if I'm a grower, small-time farmer, which one do I pick, right? Is there any thought to put some type of evaluation program where you can rate these things on some type of objective scale? And then on top of that, look at the privacy, cybersecurity implications, and maybe recommend, preventative measures or which tools are safe. Thank you.
I think that's definitely a you question right now.
Yeah, so that's a great question. For those of you who are queuing into sort of the World Agri-Tech Conference that was a couple of weeks ago, our Undersecretary mentioned a new program that is coming out to focus on this, to sort of help with evaluating and testing of sort of the emerging ag tech that comes online. And I think the best response I could give right now is you'll be hearing a lot more in the very near future about that. So please don't hesitate to reach out, but there's going to be some announcements coming up, in the near future around this even more.
Thank you very much. My name is Olumide from Auburn University. Like Chris, you rightly said that we need a lot of data set. Soybean in one part of the US might not look like soybean in another part. There are so many varieties. And like Steve also rightly mentioned, we need a platform. So how about incentivizing people that want to collaborate? It's not going to be like, okay, I collect all this data, I use it for my own gain alone, leaving you out of the deal. So whoever wants to collaborate knows what they are coming into is additional way of making money while I release my data for you to do what you want to do. I'm also going to get something apart from applying the technology, the product you're building at the end of the day. I know that my data is also fetching money. How about that?
Great. Well, I'll tell you what our attempt here with it. So we have a camera system and a robotic imaging system that is part of the things that we've developed over the last few years. I see our colleague back here, Amanda Holtz-Kemp, who's been a core part of developing all of this as well. And one of our goals here is to release all of this open source and have a online place where folks can share their models or not, but that you as a researcher are the driver of your own destiny and in terms of how you want to share that. So we have, there are places online right now that do this that are much larger than just ag. We think an ag specific one might have some real value in it. And so it's one of the things we're trying to do is create where it's very easy for you to train a model, very easy for you to actually have a camera system that will survive ag, which is no small feat, by the way, because I don't care what IP67 or what IP rating most of the camera systems have out there. Good luck in ag. I mean, we are doing some nasty things in our equipment. So we have some ones now that we're on sprayers where they're spraying UAN solution, and the level of oxidation is off the charts. But it's all to say, we were trying to create that ecosystem where it's very simple for you to create and train and deploy a model to your growers, and then also to decide how you want to pursue that further than that, and that the researcher is in the driver's seat on that. So if you want more details on that, please see me afterwards, and I can give you sort of follow up on doing that. I will say, most of this is being done in the public sector. We also have a small private arm that is part of trying to make that all flow. So.
In 5 years from now, where do you think the most impact from your current research program will have on the life of, growers, producers, the people you're doing this work for?
Because I'll kick that off. I mean, right now, a lot of the camera systems that are out there are bespoke camera systems, right? They're doing one thing. And so by trying to develop a generalized platform that can pivot and provide a diversity of sort of intelligence on the farm, it really enables sort of the public sector to engage and accelerate the kinds of solutions that exist for our growers. So, everybody's sort of in search for these killer apps or, these killer solutions that are going to have broad scale impact, right? But there's a lot of, nut and bolts fine tuning that needs to be done. And there are some really killer needs. But a lot of it, in my opinion, is going to be, we have a colleague who termed this years ago called the many little hammers approach for weed management. And I think that computer vision sort of provides that same sort of element for our farmers more broadly, right? There's a lot of little things they need to be able to tighten up the system, to better understand. I mean, if we think about the sum total of where we've gone in the last 30 years with the yield map, which has been our predominant only highly spatially explicit piece of information on the farm, right? Is just what we have for yields and how does it vary across that field. We got 30 years into that or plus, and that has spawned lots of various different types of practices. And that's about the only highly spatial piece of information that is broadly available. So I think we're going to be able to start to, in the next 5 years, rapidly transition to where are your weeds, what are your weeds, what diseases are coming on, when are they coming on, and all of this is just bolt-on technology to any platform.
So thanks. Thank you for sharing the information. So my name is Quaid. I'm with a small company down the road from here. It's called Verdision. So we make products for a living and for crop inputs. So my question is related to more like a responsible use of AI. And so Steve just mentioned a couple weeks ago at the other conference, and what I heard from USDA is like there was 180 proposals was submitted in one day, and they know it's all written by AI or with the help of AI, right? So those tools are readily available for all of us. I mean, that's why we're all here today. And but like when we use those tools, how many of us have thought about what's the consequences of it? So my question is like whether from an educator point of view, from like a universities or from USDA point of view, what's your view of the responsible use of AI? Because like the comment, Steve, you just mentioned, we also hear for all the agronomists here, you also hear like particularly like for farming, it's very local. And so those models may be available in one region, may not be valid for the other states or regions, right? So from that point of view, so I want to hear your comments related to the responsible use of AI tools.
Yeah. I'm really happy to defer to you on the ethical use of AI.
Well, I mean, it's a great question, and look, you're asking two agronomists to weigh in on this, but there is a certain irony there. But I would say, at least in terms of where I think it's going to have the biggest impact over the next 10 years in ag, it's going to be the computer vision space. We're going to make use of LLMs, or we're going to make use with that, and I see there already that some abuse is already starting, where you putting the guardrails on those LLMs in terms of providing farm advice is going to take some serious thought. I think for the computer vision aspect of it is we have got to find better ways of conveying uncertainty to growers and to integrating that uncertainty. We all get it for the chance of rain, so I don't think it's undoable. When it says now, when a farmer says it's 30% chance of rain today, they understand exactly what that means. And so when it sees the output of a computer vision algorithm, how do we present that to them so that they understand the level of certainty in the map that they have? That's the task I think we have before us that will allow, because to me, the biggest ethics of it is being transparent with what you know, right? We've got this magical box out there. We have ways of measuring uncertainty that are pretty effective. What we don't have is that human communication path to how to convey that in a meaningful way. And so I think it's I think we're gonna have to engage other disciplines in that as to what communicates and scores that. I mean, we're gonna need people in adult education. We're gonna need focus group testing to really do it. I say that because we engage in some of that stuff now. And I think this is our biggest sticking point, is conveying that uncertainty when you do software testing. By the way, I'll put a plug in for, around here in North Carolina, we have a lot of discussion about what's the future of extension, because we've been having that discussion since we formed extension 150 years ago or something. But I'd say this is actually where they belong a lot, is I see a colleague back here, Rachel Van, she helped me to run software testing with our North Carolina extension agents. And they went in there, did you like this? Do you like this? Did you like this? It is hard to get to do that with growers. And for me, as considered now a statewide and a developer, it's very hard. the county agents were spectacular at that. And so I think we need that. This new digital ag and AI in ag is going to really refresh on what we can do in extension right now, because they are all looking for, like, who was somebody over here that said, like, how do we trust which AI? But we also, what the hell is this AI trying to tell me layer that I think really we need a lot of training of our extension personnel on.
All right.
You know, just to add to that one point, though, you know, it's like it's a trust-based business, right? And we know that, like, agriculture is all about trust, and so I really like your point that when we're deploying AI, when we're using AI in these systems, it's being able to also provide the evidence, right? So, like, for example, like when we're working with growers, we're putting a tablet in the cab, so there's like they're mapping what's out there, but they're also seeing it mapped, and they're seeing in the field. They're building confidence and trust in a technology because they're visually seeing and they're seeing it recorded on the tablet. So I think that is an important element of building that trust.
Steve Grease, that was a delightful conversation. Thank you so much. And next up, we have a 10-minute break, and then we start again the technical talks.